Today we get to do the law of sines. There's also a law of cosines that we'll learn on the next section. And we're also going to learn a new area formula for a triangle. A good mathematical joke is better and better mathematics than a dozen mediocre papers. That's attributed to J.E. Littlewood. I liked that quote. And like I was saying, we're going to learn a new formula for the area of a triangle. And first of all, though, before we do this slide, I'm going to show you the formula and where it comes from. So let's go to a blank page. Okay, I'll draw a triangle. This is a non-right triangle. And let's label this big A, big B, big C, and then so therefore opposite sides are little lowercase letters. All right. And what I'm going to do is I'm going to drop an altitude down, so yeah, from B, and call that H. And right now I'm deriving the formula, a new formula for the area of a triangle. So normally the formula for the area of the triangle that we're familiar with of the triangle would be 1/2 base times height, right? Oh, lo and behold, those are exact letters that I have on my triangle. So little b, I didn't even plan that. Little b is the base, h is the height, and take half of that product and you'll get the area. Now what we're going to do instead, though, is we're going to rewrite this a little bit. We're going to use angle A, so over here on the side. I'm going to work with angle A, and I'm going to look at the sine of angle A. And to do that, to do the sine of angle A, I need to use a right triangle. So I'm going to be using just this triangle here. Because this is an altitude, I know that that's a right angle. So sine is SOHCAHTOA, so it's opposite over hypotenuse. So it's going to be H over C. Then what I'm going to do is I'm going to solve this for H. So I'm going to multiply both sides by C. And I'm going to get that H is equal to C sine of A. And then I'm going to come back over here to my original area formula, and I'm going to bring along the 1/2 and the b, and then I'm going to replace the h with my new expression here, c sine of a. So this is a new area formula. Notice that, oh, this is, I should say area of a triangle, not to be confused with this a. So angle A is here. Notice that B and C are the sides on either side of angle A. So angle A is the included angle between sides C and B. If you were to do a similar proof with, like, instead of using angle A, using angle C, you could come up with a total of 3 different variations of this formula. So another way you could write it is the area is 1/2 AB sine of C, or you could do 1/2 AC sine of B. So those are 3 new formulas. They're all really the same formula, just different variations based on the variables. Okay, now we're going to use that formula. We're going to go back to where we were. It says we have a sailmaker with a very pretty sail. Designing a sail that has those dimensions. Based on the dimensions, we need to find the amount of fabric. So we need to find the area of the triangle. So I'll say area equals, and looking at the diagram, I know angle A, so I'm going to be using sine of angle A, and then I know that it's going to be 1/2 times the sides on either side of A, so that's going to be B times C. So in your formula, you'd find your angle, and then the 2 sides that flank it are the 2 sides that go here, and then you still have the 1/2 out front. So now all we have to do is plug in the values. B, and we're all in the same unit, so that's good. 2.13, C is 2.96, sine of angle A, 73 degrees. And then we'll go to our calculator. And do check to make sure you're in degree mode. Are you not going to turn on? Okay, it's already in degree mode. Man, it doesn't like me today, does it? Come on. I have to move it more towards the middle or it doesn't perform very well. So I'm going to have, I'll just do 0.5 instead of the 1/2, times 2.13 times 2.96 times the sine of 73 degrees. And we get 3.01. And that is going to be meters squared since it's an area. And I'm just kind of looking at it to make sure it looks reasonable. Okay. Next. Okay, those are the three formulas that I introduced earlier. If you want to pause this and copy them down again, you can. Example 1. Determine the area of a triangle. So I'm going to let you, this is pretty much done at the same one we just did. So you can pause it and do it on your own, and then I'm going to I'll write the setup and then the answer. So it's going to be 1/2 times 3 times 5 times the sine of 40. Hopefully I already have that written down here somewhere. You should have gotten 4 and they do want us to round to the nearest tenth. 4.8 meters squared would be your answer on that one. Same deal, try this one on your own. So again, the setup is going to be 1/2 8 times 12 times the sine of 86 degrees, and we get 47.9 feet squared as our answer. Oh, cool. Now we get to do the law of sines. I do my proof a little bit differently than the ones in the book. So I'm going to draw another triangle, the ABC triangle. Pretty much like I did before. Oh, I called this one B, and it doesn't really matter. Let's call it ABC. Little a, little b, little c. And my favorite way to do this proof is to do it similarly to the proof I just did for area. I'm going to drop an altitude down and call it h. And then I'm going to find the sine of angle A, just like I did on that other proof. And that I'll be using just this right triangle here on the left, so the sine's going to be opposite over hypotenuse, h over c. And then I'm going to solve, well, we'll just do that. And then I'm going to come over here on the other side and use this other triangle and find the sine of c, angle C. And that's also opposite over hypotenuse, h over a. Then I'm going to solve, I notice that I have an h in both of these equations, so I'm going to solve for h on both by multiplying this one by both sides by a, so I get that. Over here, I'm going to multiply both sides by c, so I get that. Now I can make these two equations equal to each other since they both equal h. I'm going to run out of room, but I'm almost done anyway. Whoops, I lost the a. And then all I have to do, I'm going to divide both sides by c and divide both sides by a. I'll do it both at once. How about AC? So I'm dividing both sides by AC, which is a legal algebra move. If I do that, these c's are going to cancel, these a's are going to cancel, and I'm going to get the sine of angle A over little a equals the sine of angle C over little c. And then you could also do it do your triangle a little differently, like use your different altitude, and you would also see that this is equal to the sine of angle B over little b. So there's the proof for the law of sines. This is the law of sines right here. It's a relationship of how these angles and sides are related. So here it is again, if you want to pause and write that down. And a few things to notice about it. You can use the law of sines to find missing sides and angles when you have angle, angle, side, angle, and SSA. It won't work, so the law of sines fails for side, 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 and side, angle, side. And that's where we'll be using law of cosines for those two. Or at least we'll be starting them with law of cosines. So just a heads up, this is going to require law of cosines, which we will be learning in the next section. Example 2. So we're going to solve this using law of sines. All right. Well, by solving the triangle, that means we're going to find all the missing sides and angles. And right off, notice we have 33 and 28. And if we can add those up and subtract from 180 to get angle E. So let's see. I was going to look to see in my notes if I already have that figured out to save time. Indeed, that's going to be 119 degrees. So angle E is 119 according to my notes here. Then we can find E and D. And in this case, it doesn't really matter which order we do it in because we have enough information to find either one of them. So I'll just find E, let's say. Now with your law of sines, let me write it down again. Now in our case, we have D, E, and F, so it's going to be sine of angle E over little e equals sine of angle D over little d equals sine big F over F. Notice that I know my angles, but I want to find my sides. I like to have the thing that my unknown on in the numerator. So instead of writing law of sines like I just did, we can flip all of these and write it like so. As long as we do the reciprocal of everything, it's the same relationship. Because with proportions, you can flip those like that. I'm going to use this bottom version because I find it easier to solve. So I'm going to use, I need to find E, so I'm going to have E over the sine of the angle opposite E, which is 119, equals, and then I'm going to choose D, how about? No, let's use 15, because let's use that one because it's given. And then 15 will be over the sine of 28. Do not use all three of those ratios, you only need two of them. So we'll have this, and then to solve for E, we simply multiply both sides by the sine of 119. See, it makes it really easy to solve when my unknown is in the numerator. And so I'm going to have 15 times the sine of 119 divided by the sine of 28, and I'll go ahead and do that on the calculator. So if you want to follow along, it's going to be 15 sine of 119, close parenthesis, divided by sine of 28. I recommend setting up all the algebra first, then doing the calculation at the end in one line. Just do it all at once on your calculator. You're going to have less rounding error that way. And it does say to the nearest tenth. So 27.9, that's E, that's a side length. Then we'll do the same thing to find D. So I want it, D's my unknown, I want it to be in the numerator. That's going to be over sine of 33 equals, and I'm going to use 15 again, 15 over sine of 28. So I need to multiply both sides by sine of 33. Again, please do your setup first, then just put all of this into your calculator. 15 sine of 33, whoops, I lost the 3, didn't I? Divided by sine of 28 equals 17.4. And that's another side length. Then I just kind of take a look at it and make sure it looks reasonable. My longest side is opposite my largest angle. My smallest side is opposite my smallest angle, so that's a good thing. I'm going to go back a sec. Is this the same? Okay, it's a little bit different. Solve the triangle round to the nearest tenth. So again, we know two angles, so I would find the third angle first. So that's going to be 180 minus the sum of 36 and 39. So that's going to be 105. And then let's just find R. So R, we need to put it on top. That's going to be R over sine of 39. 39 is opposite R. And then we know 10. We have to use 10. It's the only other side we know. 10 over sine of 105. Multiply both sides by sine of 39. I'm going to do this a little kind of quickly so I don't waste up your time. And then I'm going to type this in my own personal calculator because it goes a lot faster. Sine of 105. And I'm getting, oh, my personal calculator's in radian mode. I got a negative answer when I typed that all in my calculator. And then I was like, oh, wrong mode. So if that happens to you, then you're probably in the wrong mode if you get a weird answer. 10 sine of 39, enter, divided by sine of 105. Okay, this time I'm getting a positive. 7, and again we're rounding to nearest tenths. So 6.5 is my R. Now I can find Q. Let's come over here. Q over sine of 36 equals, I'm going to use 10 over sine of 105 again. And So I'm going to be multiplying both sides by sine of 36. Sine of 36 here, it'll cancel. 10 sine of 36, enter, divided by sine of 105. I'm doing this on my own calculator. And I'm getting Q equals 6.1 when I round to the nearest tenth. And now that triangle has been solved. And it looks good. This is apparently it was a warm-up at one time, so maybe I'll just leave it as a warm-up. We'll skip it for now. If you want, you can pause and do it on your own. Oh, here's another one. Tell you what, I think I'll just look for the answer here in my notes and just give you the answer instead of taking the time to do it. Oh, if I even have the answer. It might be in my book. Let me find it. Okay, 2B106. Okay, here are the answers. Measure of angle N is 18 degrees. Little m is 4.7. And little p is 4.0, if you decide to do that on your own. Right, now we're going to look at something called the ambiguous case. This is probably one of the hardest thing about the law of sines, because up till now it's pretty straightforward. So, one of the situations you can use the law of sines in is in side-side angle. And remember, if you spell that backwards, you get ASS, which is kind of like an alert. When you have an ASS triangle, you have to proceed with caution because it's not always straightforward. There are actually various triangles that are possible to get in this situation. And we'll just go ahead and do it. So there's two situations, and I would highly recommend writing this down. So first situation is that the angle, because it's ASS, so we have an angle. Angle A, or whatever the angle is, I'm going to just call it angle A, is acute. That's the first scenario. Now, within that scenario, there's going to end up being 4 cases, 4 different things that could happen if angle A is acute. So let's draw a nice picture. Highly recommend you write this along with me. Here's angle A. And we're given angle side side. So here's angle. Let's call this little b. Actually, I want to use the same notation the book uses. Yeah. And then we are also given side A over here. So here's angle side side. Oh, sorry, a little bit of a headache. Okay, first case. Little a is greater than or equal to b. If that's the case, will we have a triangle? Yes, because if little a is bigger than b, then it has to swing way out here somewhere, and it's going to form a triangle. So we will end up getting one triangle if that happens. Second case. There's an altitude here called h. By the way that we're going to get h, because you actually have to find h, is you're going to use the right triangle on the left, and remember again, sine of angle A is the opposite over the hypotenuse. So that means that h is b times sine of A. Something to write down and box in, because you're going to be finding h. If this side A is the same as h, then what type of triangle will we have? Well, we'll have a right triangle, right? So when A equals h, we have one right triangle. Third case. A is less than h. Let's make an A that's smaller than h. Say it's only that big. Angle A is already established, B is already established. Little a, if you swing this little yellow side down, is it ever going to reach the other side down here to form a triangle? No. So we actually don't even have a triangle. There is no triangle at all. So if you get one of those, you get to just stop and say, okay, I'm done. I can't do any more. This is impossible. There is no triangle. And then the fourth one is the trickiest one. That's when A is between h and b. So A is greater than h, but less than b. And what happens with that, I wish I could animate this. I mean, there probably is a way to animate it. I just don't know how. So let's say we'll do an orange one. Make A be larger than h, but smaller than b. So that could be actually the one I've got drawn here meets that criteria. So this orange side here is bigger than h, obviously, and it's obviously smaller than b. Well, I could also think about this being on a hinge. I could also swing it in, and it could fit in here, couldn't it? And guess what? I have two triangles, because we'll highlight them. We'll do one in light lavender. I have, oh darn, I don't like this. I want light lavender, by golly. There it is. Okay. We could have this big one. That's one of them. And I'm going to attempt to get a different triangle. Yes. Or you could have this little one in here. So there are two. I tell you, this thing. There are two triangles possible, and you have to solve for both of them. That's called the ambiguous case. Because what's ambiguous, we don't know. Is it the big one or the little one? So you have to find them both. And that one takes the most work, obviously, because you have to find missing sides and angles for two triangles instead of one or none. All right, so this whole page is when angle A is acute. Now let's go to a new page and discuss when angle A is obtuse, or right. Fortunately, this one's easier. That's supposed to be right. So let's draw our situation. Here's angle A, B, and then, oh, it's supposed to be obtuse. What am I thinking? Let's go back. It's not right. Oh gosh, we got 10 more minutes or so. I try to keep these to half an hour. Okay, obtuse. Here's angle A. So this would be little a, and this would be little b. So if b, so first case, b has to be greater than a, right? If it was equal to a, would a triangle be formed? No. So as long as b is greater than a, then we're going to have one triangle. Or if b is less than or equal to a, we will have no triangle at all because it's not long enough to form another triangle. So those are the two cases with an obtuse. I'm going to make sure that looks right. Oh, you know what's wrong? Silly me. We need to fix this a little bit. I'd labeled it wrong, and that's bad. This is not acceptable. We need to fix it. Let's redo this. I knew it just didn't sound right. Little a is here, little b is here. So if a is greater than b, we have one triangle. If a is less than or equal to b, we'll have no triangles. So that's better. Now that is correct. So this is what you want to write down. Now back to our notes. Here it is, all summarized from the book, so you can write that down if you want. This is talking about how to solve an angle side-side situation. Notice here we have to find, oh, it doesn't say, we have to find the number of possible triangles. We actually have to find h. I don't know why they didn't write it in here. And obviously when one angle in a triangle is obtuse, the other two obviously have to be acute. All right. What I want to do, because I'm going to run out of time on the video, I'm going to skip this one. It's in the book, I do believe. Maybe not. But I want to do this one right here. Let me see what's on the last slide. Let's do this one. And we can always do some of these others in class too. So, determine the number of triangles that can be formed when A is 11, B is 17, and measure of angle A is 30. So angle of A is 30. It's an acute angle. Let's draw it in its usual place here. 30 degrees. Little a is opposite it, so that's 11. Little b is here, 17. Okay. The very first thing you must do is you must find h. I cannot emphasize that enough. Please do not skip that step. Look back in your notes. Notice that h is b sine of a. I'm going a little fast just to save time. So we're going to find h. It's going to be b, which is 17, times the sine of 30. Well, I already know the sine of 30 is a half, because I have it memorized. So 17 times a half, half of 17 is 8.5. H is 8.5. Well, look what situation we have. 11, this little a, is bigger than h, but less than b. So that means we have the ambiguous case, which you might have guessed, because I wanted to make sure and do one of these so you know how to solve it. So if I go to my orange, if it'll let me do it. Okay, good. So one of the triangles is here, the other one's going to be right there, this little one right here. Let's highlight that so you can see it, if it'll highlight. Oh. Let's make it light so it doesn't cover up everything. So this little triangle here is one of my triangles, and then the great big one is the other one. See, it just doesn't want to switch. It's really annoying. Great, so we found h. We now know that we have two triangles. So we're going to go set out to solve these. Let's do the big triangle first. So that's this whole big thing. And we can use, so we have this side, this angle. We have this side. We need to find this angle here, which is going to be big B. Big C, little c. Since big B, it's opposite little b. Now this time I don't know the angle, so I'm going to put sine of b on top, because I want my unknown variable on top, over the side opposite it, equals, then that's going to be sine of 30 over, lost my train of thought, 11. And then to solve for sine of b, I'm going to multiply both sides by 17. Those cancel. So I'm going to do this on my calculator, and then I'm going to do inverse sine to get angle b. I'll do it here so you can see it. Let's clear that off. So I'm going to do 17 sine of 30. I already know that's a half, but whatever. I'll just type it in. Divided by 11. Enter. Then I have to do second sine, second answer, to get the actual angle. So angle B is 50.6. We'll round to the nearest tenth degrees. That's on the big triangle. We're not going to write these on the figure because I have two triangles there. It's going to clutter it up. But what I am going to do is I would like you to box in your answers as you find them and label them so I know what you just found. Actually, I think I will write it in here. I need it there. Okay, now we can easily find angle C, this one here, because we know these two angles. So the measure of angle C will be 180 minus the sum of 30 plus 50.6. And I'm going to just do that on my little calculator because it's faster. 180 minus 30 plus 50.6 in parentheses. So 99.4. So I want to box that in because that's another piece of information. And now I have all three angles. I have two of the sides, so now I just need to find little c. I want my unknown on top, so little c over sine of big C, which I just found is 99.4 equals, and then I'm going to use 11 over sine of 30. And then I just multiply both sides by the sine of 99.4. Sine 99.4, that'll cancel. 11 times the sine of 99.4. I'm doing this on my own calculator. And then divided by the sine of 30, which is 0.5. So I'm getting 21.7 for my little c. And that's centimeters, so put units on there. Okay, those are the missing parts of the big triangle. Now listen very carefully to work with the little triangle. We're going to look at some geometry. I know I'm getting close to the end here. Oh, let's go to a new color. How about red? If it'll switch. Okay. Let's get rid of this. I need workspace. All right. Back up here. Remember, so okay, this is 11 centimeters. This is also 11 centimeters, right? So that makes this triangle right here isosceles. So because these two sides are congruent, remember that the base angles are also congruent? That means this is 50.6 degrees. That's why I didn't mind writing the 50.6 on there. So that's one idea from geometry. There is another idea from geometry that will enable us to find this obtuse angle. Remember, this obtuse angle and 50.6 are a linear pair, therefore they are supplementary. Therefore, to get, so this is going to be big B on the little triangle, the measure of angle B will be 180 minus 50.6. So let's see, 180 minus 50 is 130, but it's 129.4. So the measure of angle B is 129.4 degrees. That's important. That's one of the things we needed to find, so I'll box it in. Okay, so now on my little triangle, I know these two angles. I can add them up and subtract from 180. Actually, I could do that in my head. So that's going to be 30 plus 50.6 is 80.6. So 180 minus 80.6 is 99.4. That'll be the measure of angle C, degrees. Okay, so now we have all of the angles of the little triangle. All we have to do now is find one side, this little C right here, because we already know these two sides. And that's going to require the law of sines, so I'm going to just do it here in this little bitty space. I know I need my C on top, sine over the sine of little c, which is this little angle here, which is, oh, it's actually not, oh. I'm looking at that. Yeah, I guess. So this 11 is actually really quite narrow, probably. It's not drawn to scale. Anyway, I just had to kind of think about that. 99.4. Anyway, equals little c over that angle. And then we need to use the 17 again. Over the sine of the angle opposite 17 is this angle here, which we found to be angle B, which is 129.4 degrees. And then we're going to multiply both sides by the sine of 99.4 and multiply all that out. And I'll do that on my calculator. And you can follow along on yours. It's going to be 17 sine of 99.4, enter, divided by the sine of 129.4, enter. And I get 21.7, and that's just not making sense. That seems odd to me because it's longer than this one. That just doesn't make sense. It makes me wonder about this problem. It's the same answers I got last year. Maybe I didn't think about it as much last year. But this year it's seeming rather strange. Did I get a little c? Oh. What am I doing? No, it's wrong. It's not right. What did I do wrong here? I did something wrong. Oh, this is silly. Yeah, these are wrong. That's what I was going to say. That just didn't seem right. Oh, I'm so sorry. Let's fix it. Buggers. Okay, something isn't right. I made some kind of a mistake. See if I can find it real quick. Okay, so we did 180. Oh, I made a mistake right here. Well, no, that's 50.6. Oh, great. Okay, 180 minus 50.6. 129.4 is this angle. That makes perfect sense. Alright, let me try this again. 180 minus the sum of 30 plus 129.4. Well, 20.6. What the heck? I don't know what I just did earlier, but that's 20.6. So sorry. I hate to make mistakes and that gets confusing for you. Darn it anyway. Oh well. 20.6. Okay, so let's redo this. I knew it just did not seem right. So I've got little c over the sine of 20.6 equals, and then I've got 17 over the sine of 129.4. Let's see if I get a better result this time. 17 times the sine of 20.6 enter divided by the sine of 129.4 equals. That's better. C is 7.74, or 7.7 if you round to the nearest tenth, and that's in centimeters. So if you were working along with me and you were getting a different answer, maybe you found the error before I did. Kudos to you. Good job. Okay, well, we finally did it. We got all the missing parts of all the triangles. And we are over 30 minutes, I'm pretty sure. So we'll just do these other ones in class, or you can try them on your own. And we'll see you later.